Hello again. This is Math 2115 coming to you from the College of DuPage. And the title of this lecture is A More Elegant 91 Function Proof. This was problem number 5 on your midterm, and a student asked if there was a non-brute force way to do it. And I spent some time pondering that afterwards and wanted to share this with that student and the rest of you. As always, when watching this video, please be an attentive learner. By way of introduction about elegance, I want to make mention of the mathematician Paul Erdos, who often referred to the book in which God keeps the most elegant proof of each mathematical theorem. During a lecture in 1985, Erdos said, "You don't have to believe in God, but you should believe in the book." People keep track of Erdos numbers in math. As a tribute to Erdos and his incredible collection of published works, the Erdos number was created. It's calculated as follows. Erdos himself has an Erdos number of 0. Anyone who has co-authored a paper with Erdos has an Erdos number of 1. Anyone who has co-authored a paper with someone with an Erdos number of 1, but not directly with Erdos himself, has an Erdos number of 2. Each time the collaborator is one step further away, their Erdos number is increased by 1. I guess that's recursive, isn't it? A person who has never collaborated with anybody with an Erdos number has an Erdos number of infinity. Amazingly, over 40,000 people have Erdos numbers of 3 or lower, and the current highest finite number is 15. Although this is almost certain to rise as mathematicians continue to work together in the future. Now, this proof is perhaps not good enough for the book, but it does beat the brute force approach that I worked through with the student during office hours. So this is a more elegant approach to show that m of n, the 91 function, equals n minus 10 if n is bigger than 100, and m of n plus 11 if n is less than or equal to 100. And the proof that we're going to do is that this reduces to this. M of n is n minus 10 if n is bigger than 100, but it is always 91 if n is less than or equal to 100. And this is famously called McCarthy's 91 function. So let's look at the proof. And it reminds us of induction. For n greater than 100, equality follows from the definition of m. If n is greater than 100, we have this, and it's n minus 10. So that is done. For n less than or equal to 100, we're going to use a strong induction, and we're going to work downward from 100. Can be used. And we have to do this in steps. So for 90 less than or equal to n less than or equal to 100, we know that m of n is equal to m of n plus 11 by definition. So then m of n plus 11 is going to be larger than 100. So this is going to end up being m of, and this is going to be n plus 11 minus 10, which is m of n plus 1. So you see, between 90 and 100, m of n is always equal to m of n plus 1. So m of n then for those values is the same as, and it keeps going up by 1, so it eventually will get up to m of 101, which is going to be equal to 91. And so for n less than or equal to that, that can be used. And we're going to use that as the base case in the induction. For the induction step, let n be a number less than or equal to 89, and assume that m of I is equal to 91 for all n, or excuse me, for all n that are less than I is less than or equal to 100. And again, we're doing induction here, so we're picking n, and we're assuming that this is equal to 91 for all of those. Now we have to show that's true for this n as well. So for this n, m of n is equal to m of m plus 11 by definition. But this is equal to m of 91 by the induction hypothesis, since n is less than n plus 11 is less than or equal to 100, which is equal to 91 by the base case. This proves that m of n equal 91 for all n less than or equal to 100, including even negative values. You have to think about this for a while, and I hope you do. In closing, for now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. Now, more than ever, also, take care of yourself and of each other. May God bless you all.